What I was thinking about, I'll start with the very basics, sort of decompose some of the verbiage that actually goes around AI. Uh, the idea would be to help give you simpler, more relatable mental models about thinking some of the AI related pieces. And then from there, it's open-ended. It's really upon like what kind of topics you guys would want to talk about. A little bit of background about myself. My name is Amod, Malviya. I've been in the technology industry since 2002. Have seen different cycles of tech buzzwords go up and down. Started working with AI first in 2006, 2005 actually. So seeing different variety of AI since then. And yeah, I mean, professionally, I was the CTO of Flipkart from 2010 to 2015, and founded a company called Udan. So yeah, that's a bit of a background about myself. I am involved in the AI circles in Bangalore, where we, sort of have communities of people coming together and trying to deconstruct what's happening in AI. So I'll be using a lot of that background to share whatever it is that I'm planning. Okay. So how many of you have some sort of a technical background in AI? Okay. Okay. Few hands. So the like at a base level, what we were to think about is AI is something that learns functions. Okay, function is, you guys would remember f of x, that magical symbol that you would have come across in school mathematics. The idea is, given an input, there's some black box that input goes in and some output comes out. That black box is what we refer to as function. The power of AI comes with this ability that neural networks, which is, we can treat that phrase as a black box. Neural networks can learn any function. Okay? Now, therein lies the magic of it, that neural networks are, in technical terms, we write it as universal function approximators. Okay? So you can give it any function and it would actually figure things out. Now, this notion of any function gives you an infinite space of possibilities. For example, given a CT scan, detecting whether there is tumor somewhere in this scan is ultimately a function. When a human radiologist is actually going through that image, they are actually looking for patterns that they have trained their brain on, and that pattern is a function. Okay. So, because neural networks can approximate pretty much any function, therein lies the power of AI. Okay, rest everything you will come across words like CNNs, RNNs, transformers, GPT. All of these things are how these neural networks get assembled together, and how does flow of information happen between them. Okay. So instead of getting into individual classes of neural networks, I think I'm just going to lay it down here. The reason why I want to talk about it is, one, to give you this is not simplifying things. This is the reality that neural networks can learn any function possible. Okay. So one is helping you understand where does the power of AI actually come from. Second is so where does the power come from? Second is this thing about that without training, if you cannot provide sufficient input for your neural networks to learn those functions, it's not going to be effective. So the power of data comes out to the fore really in a really strong way. Somewhere in our discussion, I would want to talk about open source models. Okay, but something for us to bear in mind, that the way we train, the quality of data that we train it with, these things actually become very important. One of the newer learnings in the industry is that it's much better to have higher quality and higher volume of data being put out than just blindly increasing the number of parameters in the model. Number of parameters is, you can imagine it as the complexity of the function, the number of weights or the number of numbers involved in approximating that function. So this training piece is actually pretty important for all of you to bear in mind. Third is that not all functions are necessarily complex. Okay, for example, if I were to estimate the path that a particular projectile is going to take, it's governed by standard physics. The formula for that is well established. I don't have to have a neural network estimate it out. Another example is, yesterday we were having a discussion with one team for whom standard statistical models were actually of optimization. We refer to them as OR problems, operations research problems, where you are trying to figure out an optimal answer given a bunch of constraints. You don't have to have an AI for that. You actually can run with much more efficient algorithms simply because you know what kind of problem you are dealing with. So not all functions are complex. So this particularly when tech buzzwords sort of come around, it's easy to get sort of lost in the crowd and run essentially looking for that nail sort of a thing. You have a hammer and you're looking for a nail. So it's a very important thing to bear in mind that not everything requires AI. It's only when the nature of what you're trying to solve, that algorithm, is too complicated to actually represent in a deterministic way, should you get into AI. Okay, so summarizing documents, for example, the variety is so large is that there is no deterministic algorithm that you can actually specify. Okay, so it's much better to use an AI there. On the other hand, if you were to be doing simple keyword lookup, okay, you don't have to use an AI. All right, so these are the 3 points that I wanted to bring up. Then I had a bunch of things that conversations that I typically get into in communities like these. I wanted to put them out there, and we can go over them based on the the kind of thing that you guys would prefer. One is future of open source models versus proprietary ones. Another one is AI and jobs, the future of jobs and stuff like that. There's misinformation and societal considerations as well. GPUs, a related thing is policy. To what degree governments may want to control it, can they control it or not, and stuff like that. So those were the sort of themes that make for some interesting discussions. If anybody is interested in things like quantization, fine-tuning, LoRa, nerves, those are things that we can, but those are pretty technical topics. I wanted to just start off with a simple way to imagine AI, a black box that can approximate any function. The quality and quantity of training that we put through it becomes very important. And most importantly, not all functions are complex. Not every problem requires an AI. I just wanted to sort of bootstrap our discussion with that. Any comments or questions on this? And if you want me to add to the list of topics that we could actually talk about, I'm happy to. Okay, go ahead.
And a topic to add maybe, which is, I've been wondering if we're moving towards a different kind of singularity in thinking, because of the way, the fact that large language models are, at least up until now, English-based.
Yeah. Okay. Fair enough. let's just enumerate topics for now. Let's take 2 minutes to enumerate any potential topics, and then we can sort of quickly get into these.
So one question I had is where we are all independently solving for different use cases. Is there a way that we can kind of collectively come together? Let's say we're solving for law, for example, with AI.
Yeah.
Can you talk about frameworks that can enable all of us to?
Yeah, let's. I'll treat that as sub-bullet of when we are talking about the future of open source models versus proprietary ones. Sure.
Can you talk about the difference between the classic ML models like NLP and now the different possibilities that LLMs are offering, and do we see that progressing to something else as well?
Okay.
Just an extension of that, we keep hearing the term that this can be done by generative AI out of the box. Something that
Sure.
we would see through classic ML mechanisms. Now people say out of the box. But surely people have been comparing and seeing how does this stack up against this, the out of the box capability which it seems to have acquired versus the traditional ML. Maybe if you can share some of your insights.
You want specifically to focus on the generative AI piece or the out of the box?
More that when these functions, some of these functions are happening, say out of the box, say summarization functions or functions like that. In your experience, have you seen that as being? Do you see that as having its own challenges? In the sense that
Fair enough.
better to, for some situations, better to ignore that and still do classic ML.
Fair enough. Let me, if I can split that up into 2 pieces. It may not make immediate sense, but I'm just taking note of this. One is related to the out of the box, related to open source or proprietary, and fine tuning the degree to which that might be needed to get some of the job done. All right. I think there is enough space, but anything else that comes to mind before we start summarizing? All right. Which one should we pick first?
Maybe the open source ones.
All right. Open source models versus proprietary ones. Anybody has a point of view?
I think open source will win eventually.
Okay.
From my basic understanding, the innovation comes from the open source models more often than not, and the proprietary models are working on those new use cases and because of the resources they have at their disposal and making them better and better. And
Much as I would like that to be true, that's untrue.
better.
Yeah. So almost, the fact is, majority of the movement and development in this space in the recent times has actually happened because very, very large corporations are willing to burn away money, and for some reason willing to put out their learnings. That's the only reason why we actually have a lot of these developments. So this is one space where industry has far outpaced the academia. So academia by nature tends to be transparent and open. Industry tends to, the openness is a voluntary act, an optional act.
Are you referring to Facebook?
Facebook, Google, so the Transformers paper actually.
Transformers data.
Yeah, it's actually came in. So these things have not been developed in open source. They've been developed in private areas and actually then open source.
Even governments, right? Like Falcon and
Yeah, so that's the I think UAE is
UAE, Abu Dhabi.
Yeah, yeah.
So
So
trending a lot in the LLM.
yeah, but remember that's not a foundational change. So there are these foundational developments that happen, which is a newer kind of algorithm or a newer way to thinking about assembling these neural networks together. This is one of those sciences where empirical approach, where you actually tinker with something, tweak it, and actually try it out without any theory behind it. And theory sort of lags quite a bit. If one model starts succeeding and theory is trying to figure out, for example, why is it succeeding, it shouldn't be succeeding. Okay, so that is how this has been getting developed. The development of the algorithms, because it comes with significant training cost. Training of these models actually is a huge, massive cost. Like tens of millions of dollars is nothing when you are actually considering training some of these models. Okay, so these actually get done behind the scenes. What is happening is once a model gets put out, there are some of these organizations and sovereign nations in case of Falcon, where they've actually used what is well-known algorithm and applied their money on top of it and actually put out an open source model. Facebook is shockingly doing a great job of it. So yeah, I mean,
But this Orca is different, right? Microsoft's.
I've not tried that, so I cannot comment on that. But you know, Facebook, then the UAE, a bunch of other you know companies have also committed to developing these things in the open. But I want to be very clear that training, because the training cost is significant, so these things tend to be developed in. Progress happens privately. By their generosity, they actually put things out, and you know things end up being developed. Incremental progress, open source tends to do very effectively. Okay.
Is this a pattern across multiple areas? Because in pharma, this is the identical thing people are saying, that all the innovation is happening inside because all the data is inside.
So in cryptography, this used to be the case as well. So there is at least one more thing, databases to a certain degree. But then eventually what happens is that even if like the more foundational elements of it, once they get put out, once that glass ceiling is broken, it's much easier for everybody to then, imagination gets unlocked. People start figuring out, okay, I cannot use this because it's proprietary. What else can I actually do to replicate this thing? That's a much easier thing to actually do than being that first person to break through the glass ceiling. So, so yeah, I mean, OSS models versus proprietary. My personal feeling is OSS models would actually win, but the reason is probably a little nuanced. You wanted to add?
No, please.
Oh, sorry.
Finish.
The reason is that once a model gets put out, there are techniques related to fine tuning and some of these things, which allows far larger number of companies to start benefiting in a very concrete way from these open source models. Okay, some of these open source models, particularly on the diffusion side of things or vision side of things, it's actually they are absolutely usable out of the box. Even on the tech side of things, absolutely usable out of the box. But depending on the domain that you're working in or the kind of richness you need, you may need to do some fine tuning. But it would be wrong to say that open source models or some of these models cannot be used out of the box. I think more often than not they are actually used. Even at a personal productivity level, majority of these open source models will actually succeed in making you productive at an individual personal level. But if, for example, you're working in judiciary where a much higher level of either explainability will come, because that's a separate problem on its own. Yeah, much higher benchmark of accuracy might actually be needed, or much more fine-grained analysis might be needed. The larger the model today, that much poorer they are usually in terms of very fine-grained. I mean, we try to solve for it by prompt engineering, step-by-step, chain of thought, reasoning and stuff like that. But that's like a forced way to try to extract it out. The point is that if you are deploying it out in high, like in sensitive scenarios, radiology, judiciary, these are like sensitive scenarios, you would most likely need to do something on top of it. Okay? So that opens OSS models. You had a comment.
I had a very foundational question.
Yeah.
So in terms of open source models, it's a rudimentary understanding, but I understand that the source code is freely available. You can access it, you can modify it, you can redistribute it. But I was wondering, essentially what do these things really mean? Like, what do you mean that you're modifying, and how does that modification actually look like? And do you have any examples where an open source model has been, maybe like popular example where it has been modified and then redistributed to a larger scale? Because so just some background. So I've read about the open source movement as the ethos of it, but I don't understand exactly what you.
So let me lay down what that process looks like. At a base level, you can imagine an AI as a network of layers of neural networks. Okay, information flows from the input side, pops comes out the output. These neural networks individually are represented as a big matrix of numbers. Okay, and what you're effectively doing is you're doing a bunch of matrix operations like multiplication, addition, and stuff, and pop comes the output. That is what is actually really happening, practically speaking. when we talk about an AI model being distributed, there are two aspects of it. One is that the code is much simpler. Like it is super simple kind of code that one could come. It's one of the most simplest kind of codes that you can actually come across. Code is not the tough part here. The complexity comes from how these matrices that this code operates on. That is what takes up the size. So when you talk about 60 billion parameter model, it means that there are 60 billion numbers at a high level, numbers in there that are getting multiplied and added and manipulated to receive the output. When you talk about fine tuning, which is you've taken a model and you want to train it, say for example, specifically on judicial data, or in their case, Insurance Samadan is the company that they represent, the insurance related domain information. When you're trying to train a model on that, what you do is you pick an existing open source model and you start running a bunch of those training steps specifically that capture the training data is representative of the domain that you are trying to train it on. Okay? Training effectively means you give an input, output is not as per what you wanted, so you consider a certain amount of loss and you back propagate it and you tweak the numbers in a way to reduce that loss. At a high level, that is what the training algorithm actually does. You keep on pumping, you keep on doing this until the amount of loss that you are seeing, loss is the delta between expected output and what it actually is, until it starts converging to a really, really low number. You keep on repeating this at a high level. Okay? So fine tuning is pretty much the same thing. One of the things that happens is, and one of the reasons why OSS, this is the nuanced piece which is less understood. The base ability to understand concepts is actually this notion of understanding a language, being able to reason to a certain degree, is actually not training data dependent as much. Okay, so there's a base level brain you can imagine that gets created in the open source world. It's much easier. I'm talking about in practice demonstrated, like provable statement. It's much easier to layer a small amount of domain understanding on top of an existing model through the process of fine tuning. There is some additional details there, like quantization using LoRa and stuff like so LoRa plus quantization, which makes it almost like you have a base brain, which is your open source model, and you're almost like deploying a plugin on top. Have you seen the movie Matrix?
Yeah.
And this guy wakes up and I know Kung Fu. Right? That's the thing that I'm talking about. What you're doing is you capture that fine-tuned delta of this big matrix of numbers. We call them weights. So through fine-tuning, you're getting that delta weights, and every time you want to deploy a new skill, you sort of throw those extra weights in your model, and suddenly you have all of that knowledge available to that network. Okay? So which is one reason, my personal hypothesis is that over time, speculation, which is still very speculative, I want to be very clear about it. Over time, what will happen is in all of the devices, there would be a base level LLM available in our phones, in our TV and stuff like that. And a lot of the individual customization or the domain specificity would come from as that additional plugin that gets slapped on top of that base model. So you train that, and because that delta is actually tends to be much smaller. The much larger piece is just that core ability to understand relations in the language tokens and stuff like that. That's a much thicker thing, and it also captures a certain level of base reasoning.
In that case, does it make sense to even do the fine tuning, or is it going to get to a point where you can build just a top layer and plug it, and that multiple LLMs could absorb that layer? The way you described it, saying that the phone will have a base LLM, and you just download a plugin that will operate as a kind of fine tuning. So then, how far are we from a situation where you don't really have to worry too much about training a specific LLM? you kind of develop a thin training layer.
But
which
that is what
domain
you
specific.
that is what you do anyways today. Very few people are actually training foundational LLMs. So personally, I am not very bullish on the ROI on training foundational LLMs.
Right.
Okay. See, foundational LLMs is like you can imagine training a child up to a level of class 5th, probably. Okay. Age 7, 8 types. Okay. So you're getting them to enough level where you can converse with them and you can teach them new tricks or something like that. Okay. So a base level LLM, you can imagine it as that, and then you are just sort of the fine tuning part is getting them to learn. For example, being able to do some basic reasoning or understanding, terms from judiciary or terms from the finance domain and stuff like that. So that is what you are effectively doing. So even today, majority of the companies, that's what they end up. Foundational LLMs is a very costly affair, and I don't think that cost is going to come down. Actually, one of the things that I should also talk about is training versus inference. Training is when you are, preparing those models. Okay, you are learning those weights, those matrices of numbers. Okay. Training by definition needs to actually happen because of a bunch of technical reasons, needs to happen on very high level of precision. Okay, so the hardware needs to be highly capable of large amounts of precise calculation. But once that's calculated, you can actually reduce the precision of those individual numbers. I in fact did a demo once where I reduced the size of those numbers to 20% of what they were. Okay, that video is out there. You can search for Amod Malviya quantization and you should be able to get to that video. So 80% loss of numbers and the AI was working perfectly fine without any issues. Okay, the reason is there's a theory that it talks about the geometry of deep learning. The idea is that when we are training an AI, we are developing a lot of connections in a way that the topology of how information flows in a way, it's highly redundant. So okay, so even if you were to knock off,
I see the core is still there.
It's
like fractal almost.
Yeah. Okay, so it can actually it still ends up being very effective even if you were to reduce the precision of those things significantly. What that means is at inference you can run with much more lightweight models. You train very heavyweight models, you convert them to be much lighter, and everything actually still works. Okay, with very, very little difference to it. That is something which, how did I come to that? I was trying to...
On the training, fine tuning for specific
yeah.
purposes.
So when you are fine tuning all of that, the training cost of foundational models is actually too high because the training needs to be done on very, very high precise modes. Okay, it requires much more complex hardware. So this very few people can actually do. So majority of the companies ke liye, it is going to be much more cost efficient, ROI is going to be way better if they were to pick a foundational model, any foundational model, and just do a little bit of extra training on it, that fine tuning thing. It's like getting an apprentice who you can teach some new tricks kind of a thing. But you don't have to teach them how to move their tongue to speak as a particular word or something like that, right? So that's it. Alright, so that's about some of these things. Singularity, should we come to that? Or any proposal? Which one? Next?
I mean, since we're talking about the training part, can we do the NLP versus LLMs? Because I think it will also
okay.
help to understand
Sure.
how the different training.
Sure. So let's talk a little bit about classic NLPs. Actually, so any kind of trying to understand language, obviously as engineers people started with the crudest of things, okay? Trying to figure out which words occur together sort of thing, right? So we call them n-grams, okay, where one word gets, so for example when I call out why this what comes to mind?
Polarity.
Yeah, right. So that it's established so strongly because you've heard this so many times that why, particularly with that tone, so that is the only thing that is going to come to your mind, right? So that is what we refer to as engramming. Okay, so people started off with that, just statistical correlations, etc. A lot of people initially used to think that LLMs is pretty much the same thing because some parts of how the underlying architecture of LLMs ends up being the same, but in reality what seems to be happening is that a basic level of reasoning has been an emergent property of LLMs. I'm choosing my words very carefully here. Things were not designed, there's nothing in the architecture that is designed for reasoning. Okay, so it's almost like if you can get anything to learn enough about language patterns, there seems to be some basic level of reasoning that emerges.
But that's true in language itself. For instance, when you say why this, there's reasoning why and this exist together. There's reasoning in the language.
There's
Why?
reasoning in the language.
In the sense that why does this follow why?
When you make that statement,
Yeah.
there is a hidden interpretation of why that exists in your mind.
Correct.
That is coming out to the fore.
Sure.
Imagine somebody who does not know English at all. Okay, if you were to be telling them about, if you were to be just sharing why this and why, for them the word why does not mean anything.
Sure.
Okay, so the hidden semantic, it's deeper than what we might actually feel initially.
For symbolic aspect of why and a symbolic aspect of this, and then
so there are hidden semantics to language, and which seems to bring out certain level of reasoning capability. Okay, so around here, for example, just to give you an idea, people started thinking that, oh, maybe multimodal. Currently, we are actually just doing text, right? What if we were to actually get, video, like visual input to the LLMs? We refer to them as multimodal. Will that greatly enhance the ability of LLMs to reason, right? For example, as kids, we actually sort of, keep on saying that car. Okay, the shape is like a car. Okay, so every time we are out there, car, right? So that process is actually going on. So people thought that it would greatly enhance the ability to reason because you are able to connect them more with the real world. But then somebody asked the question that, do blind people not have reasoning capability? Right? So the point seems to be that so long as you get anything trained enough on large scale language statistics, reasoning emerges. Now there's a school of thought that says human reasoning goes beyond just language reasoning, and I have to say that I've read both schools of thought, and I've not been able to conclude one way or another. My slight inclination is towards the latter. But one question that I keep thinking about is, would we get to advanced levels of reasoning if we wouldn't know how to speak? If both speaking and hearing is impaired, then would we actually have that level of advanced level of capability, right? For example, monkeys or giraffes, all of these folks can do basic
They
level
make
of
sounds,
reasoning,
yeah.
but cannot really sort of get to very advanced level of reasoning. Yeah.
You mean speak or communicate? Because there are deaf and blind or deaf and mute people who can communicate with sign language.
That's a good point. That's a good point. Yeah. So I think I should correct myself. It should be about communicating. So whichever mode with which they are communicating, communication seems to, so long as there is enough richness that can actually be baked into it, seems like it is something that can draw out reasoning capability. But whether reasoning exists independent of that is not something that is fully clear. Even to, like, I was going through some papers in neurology about consciousness and stuff like that, and there doesn't seem to be ample evidence to conclude that. So which is why I'm saying that it's a bit of an open question. But what is clear is that classic NLPs were essentially very It's like we invented a bunch of functions. In classic NLPs, we are inputting those functions. That when these two things happen together, then it seems like there is a this is what they mean. Okay, this is very often used by engineers when, for example, in customer support, when people are trying to classify a user's emailed this, which of these n number of questions might they be asking? So classic NLPs, have often been getting it, but very open-ended things, they actually fail miserably because again, hand-tuned functions go into it often enough. LLMs, on the other hand,
Hand-tuned functions.
hand-tuned functions as in we are writing the algorithm to a certain degree. Okay, remember the modern AI is about learning very, very complex structures, meanings that we do not know. That we, for example, what constitutes a face? How do you articulate it? There's something round up there, some triangular structure. A little above it, there is a should be two circles, but around the circle there should be something like this. And chances are low if you do not find two lines on top of those circles, right? You can try articulating what a face looks like in these terms. That's what I mean by hand tuning. The trouble starts happening. What if the face is like this? What if this was there, right? So the variety that we encounter in real world is too complicated, and that's why hand tuning fails. Okay, so that's where really the power of modern AI, because it can learn very, very one classic example that gets used is what is king minus man plus woman?
Queen.
Queen. Okay. Why were you able to think about that? Why are you able to say that? No, think about it.
Could have learned about gender.
Yeah, right. So gender, you can think about it as a hidden representation. My question to you was not about gender, right? I didn't explain what minus means. I didn't explain what plus means, and yet you were able to carry your learning about minus and plus from your basic elementary algebra and apply it to a very, very different context, bringing in a representation that I didn't speak about, right? So what happens is that when we are learning, a lot of these representations are actually getting sort of absorbed in our mind, and these concepts get stored in a certain way which we cannot articulate properly. Okay? Modern deep learning is about learning these concepts in a very similar way. Okay, so if I were to, one of the concepts that's used in modern deep learning is the concept of embeddings. Okay, so when if I were to take an English embedding, which is essentially converting a word into one of these, I call them concept vectors. What each one of those numbers means, it's difficult to say. You cannot pinpoint that this means gender. Okay, but some combination of those things would represent gender. So if I were to pose the same question to an AI, it would actually spit out the word queen. Okay, it's learning that hidden representation is what is modern AI about. That's what I mean by hand-tuned versus. Make sense? All right. So classic NLPs versus LLMs. Classic NLPs are significantly limited. LLMs seem to have firstly just their capacity for understanding structure is a lot higher because because of certain technical improvements, we are actually able to train a lot more number of parameters. I want to be clear, it's not just some major change, it's not coincidental. A bunch of technical reasons have enabled modern LLMs to exist. Before that, they could not have existed. And the second difference is that it seems to have brought out a certain level of reasoning, emergent property that we were not quite anticipating.
For someone who's seen the space for so long, were you surprised by what it was able to do?
It's difficult. I think anybody who says that they weren't surprised is probably not being fully honest. But I want to be very clear that there's also a lot of stuff that goes around about consciousness, that these are sentient. Okay, I just cannot bring myself to understanding it, particularly because like understanding how some of these things actually work. By definition, they cannot be sentient. Okay, so the surprise is there, but not to the degree where people are.
You're surprised by what functions they can perform.
I was, yeah. So any emergent behavior is usually surprising because you were not expecting something to behave in a certain way, and it's not a bug. Just to be clear, when it's a bug, you're disappointed, not surprised. This is a behavior that seems to draw out, things which we were not expecting it to be able to understand, to comprehend, to reason to a certain level. That if you were to throw a small puzzle at it, it's actually able to solve it. That's something which represents some degree of intelligent behavior. But I'm using that word very consciously. Intelligent behavior as distinct from intelligence or sentience. All right. So that's about this. Which one? Next.
I think about explainability and reliability.
Explainability, how, like, or how do you bring reliability then if it is so?
Yeah, so these are two different things, but related in a certain way. Reliability is, when you are repeating the same situation, to what degree do we end up essentially encountering the same sort of a response? To what degree you can rely on it? For example, when you are doing self-driving, when you are relying on AI for self-driving cars, it needs to be highly reliable, right? Now, reliability is often a spectrum, like you can never be like 100% reliable. Even as humans, we cannot do that. So there's always a cutoff. But explainability is actually a much bigger thing in the recent terms, where because we do not often know what kind of biases actually creep into the training data. Okay, and the algorithm has actually learned those statistical correlations, which is then reflecting in how they actually. And you would have heard about examples where when somebody is talking about engineer, the dominant pronoun ends up becoming he. When you are talking about work at home spouse, the dominant thing becomes she. I think there is it's a different discourse altogether. But the point is that explainability, when we start deploying these models into real world situations, is going to be an important thing. But here is the interesting part. There is nothing about this architecture that is explainable. I'm being honest. There's nothing about this. See, when we do classical machine learning, we learn simple functions. Okay, for example, given your age and gender and your past history of parents having certain heart issues, what is the probability of you developing heart issues? They are very well defined functions. You can explain why you got the score that you got. Okay, you can say that statistically the curve is like this. You fall here on the curve. That's why your score is X, Y, Z. Okay, your comprehension that ultimately this is an output of statistics, your awareness is much higher, and it allows for higher tolerance for explainability. But the moment you get into something that behaves like a human, when something is behaving like a human, that tolerance suddenly dips significantly. Okay, because we start associating, I'm sharing my personal thoughts here, this is not in literature in any way. When we are dealing with systems that are behaving almost like a human, we tend to immediately start attributing human-like attributes. So our tolerance for biases actually becomes much lower. Okay, so if somebody actually starts commenting or responding in a way, if a system starts responding to me in a way that is regressive to me, okay, and is a representative of certain social behavior that I am bothered about, it would hurt me a lot more than if I were to be dealing with a classic ML model, because it's a graph. I'm here on the graph. A lot of people are clustered around me, so I can understand, right? That is what would make real world deployment of some of these systems hard.
So in just as an anecdotal example, I was working with Loyal Labs, which was trying to query a set of write-ups that I've already done, and they were trying to query it against malnutrition, for example. So in terms of explainability, when we said, okay, how do you explain, so how do you arrive at, so out of a given data set of about 20 articles, it was supposed to pick articles that related to malnutrition. So yes, it picked articles, about 5 articles, and then when we queried, how did you arrive at this answer? I was surprised at 3 levels. One was fair enough, which is the line itself had malnutrition in the line, so that was fine. The second kind of slightly surprised me because it was talking about the hemoglobin count drop because she did not have her diet was sort of low, and that talked about it. The third one surprised me even more, where they were talking about breastfed as a baby, for example. So like it's able to do picking articles about malnutrition, and it's going to go all the way several orders of thinking higher, and I don't know where those
this
orders.
Was a classical model? Was this a
LLM?
LLM.
Yes.
Yeah. So I think in some of those things, now the real question is the reasoning learned by it from literature, or is the reasoning created at runtime when you are querying?
Yeah.
Okay. Now that becomes important, and because I suspect it's not created at runtime for LLM, and the reason is LLMs are actually quite poor at long range reasoning, higher order effect. Okay, which is the one big reason why we actually need to tell it often enough, walk me step by step in your reasoning process, because LLMs by nature are actually transducers. They are actually just predicting the next word based on the previous one. The more you ask it to detail it out, that much more at that moment, that much more context it's actually gathering. It's almost like it was earlier talking in a zoomed out level. You are forcing it to zoom in and walk you through. If that reasoning that you're talking about was native to it, we wouldn't be needing to do that all the time. Okay. Another example of this native reasoning versus a learned reason. Learned reason is what? I read about this reason somewhere. Okay, so it was there in one of the training data that was fed to me. One good example of this is there was this, I think GPT 3.5 ke release ke time pe, there was this thing that was done that somebody had published the scores of GPT 3.5 or 4, I don't remember, on some maths tests. And there were these researchers who actually did it on all the test papers that had been published till then versus immediately after its release. And the score dropped like this. So something that had been performing stupendously well, okay, suddenly dropped.
So it's just remembered the reason, it's not really figured it out.
Yes.
That's why it can't do later.
That's precisely what I mean. Okay, and that's one of the things to bear in mind when something starts behaving like a human, particularly all of us who are involved in building some products around these technologies. When something starts behaving like a human, for the end user, it's going to be very difficult for them to actually understand that it's the limitations of something like that, because it's behaving like a human.
But is learned reasoning sufficient?
Learned reasoning, that's the thing now. If the learned reasoning is based on good scientific literature, great. What if the learned reasoning is based on WhatsApp chats that get exchanged?
Correct.
Right? Particularly Twitter data pe train ho raha hoonge, then it's like hopeless cause by now.
यहाँ पर ये तो पूरी दुनिया की problem है.
Haan, that's my point. That's a separate
Bad learned reasoning.
Bad learned reasoning. But that's the thing. See, critical thinking is still currently a uniquely human ability that whenever a new input is coming in, not all of us exercise it, I agree, but when a new input is coming, to be able to apply our own filters and decide at that moment whether to accept or reject that input, that is still unique to us.
That's really insightful.
So coming to the explainability piece, architecturally, it is a stupendously complex thing. It's trying to create an explainable AI is almost like trying to read the movement of atoms in your body and trying to predict how you as a human would be behaving, right? We refer to these as computationally intractable problems. Okay, so it's not mathematically proven yet, but I strongly feel that it's a computationally intractable problem. So my personal opinion.
Can I ask a question?
Sorry.
For you, does that mean that there are certain things AI should not ever do? Because a human also, like, it was difficult to explain what a face looks like, right? Smita explained why she thought of queen based on gender, but really there's so much more there, and she would never be able to explain. But Smita is one person who has only so much ability to influence all the decisions that are made in the world, right? With an LLM, things take a different scale. And if you can't explain any of the decisions any of the decisions that are made by this LLM, are there certain situations where you think then that means we should not even entertain using them?
So
in certain specific
there would be
cases?
enough people who would make that remark. I'm not one of them. I actually feel that, and I say this while recognizing the dangers that actually come with it. I just feel that the limitations or the statistical limitations of the human race. Critical thinking is a statistical limitation of the human race. Okay, it's not like individually we don't have the capacity to exercise that power. Just statistically, majority of the people don't apply that for whatever set of reasoning. It could be conditioning, it could be the economic situation, mind is elsewhere all the time or something like that. But that should not prevent us from trying to bring tools that can enhance the thinking capability, productivity capability of those who can. And when I make the statement, don't read this as an exclusionary approach to things. I am not referring to that. That's a different topic altogether. What I'm saying is just because of this explainability issue, we should not stop it. What we should do is how we productize this. Remember that this is technology. How we productize this, how we deploy this in real world. For example, in judiciary, suggesting conclusions is probably a wrong productization of it. Probably, almost definitely a wrong productization of it. However, summarizing, instead of going through like hundreds of pages of documentation, it should be possible to productize like a maker-checker sort of a system where the maker is suggesting a summary and the checker is checking how comprehensive that summary is and if any crucial point is actually getting missed out. Okay? Not going to be 100% accurate, but still going to be a lot better. The person who is actually consuming that information, by training those people specifically on not trusting on treating such a tool as an input but not as a god. We can specifically train the consumers of these specialized situations as people who can, who can develop a sense of when information is not complete or something like that. That's how we should be productizing it. But if we start productizing it as trying to replace a sensitive decision maker, I think that's going to be disastrous.
At some level, what you're saying is, if you look at the judiciary, you actually need a higher quality of judiciary. But if you have a higher quality of judiciary armed with this, you can perform that much better.
Yes.
You can't have this as a substitute for a lower quality of judiciary because they won't be able to do their job.
That's actually true. But
so therefore, you need both conditions to work together, but you get a bigger effect.
And the same thing is true for even the misinformation and the disinformation side of things as well, right? The higher quality, more educated population would actually do wonders with consuming this. Less critical thinking population is going to suffer the consequences of something like this. Okay, so for more sensitive deployments of such a product, this becomes even more crucial. And the good part is we can specifically control, we can train, because it's a well-defined set of judges or people who are consuming this information in a professional setup. You can specifically invest in training behind them. Guess what? In radiology, for example, before CT scan and some of these things actually came up, how were people actually trying to do things? People would just rely on X-ray and trying to determine, make some determinations, right? when X-rays, when high resolution stuff like CT scan or MRI, these things actually started happening, it enhanced the ability of these people to arrive at much richer quality decisions. And that's what we should focus on. Okay, now we are getting into a little bit of AI versus jobs wala piece, but that's how we should actually probably be thinking of. Explainability is, learned explainability is going to be there. So we can always train in certain situations, train the model to be able to explain, but that we have to understand that it's learned explainability, not inherent explainability.
But then that is all of us saying that there are some jobs or some areas of work that do not require that LLM,
Yeah.
right? Prediction of outcomes in a judgment. That is a place where we should not use LLM then. Or you're saying we need to design it in a way that it helps a higher quality judge perform it better.
Prediction being seen as a bunch of tasks, with the judge literally being seen as an agent.
I don't know sufficiently every intricacy of the judicial process to be able to authoritatively comment on it.
Okay.
I just feel that just with my limited exposure, the amount of time that gets wasted in the procedural part of it, we should think about, because that's where the real issue lies, right?
Yeah.
How do we get the people involved in any process to be focusing on their intellectual capacity than the operational management of processes? To what degree can we significantly improve the productivity of people by giving them the right kind of tools and abilities? That's how I personally like to think about it. But care needs to be exercised. That explainability, what we often see in these LLMs, is learned explainability, not.
So can you give an example of exactly what you are talking about? So for example, we deal with insurance complaints. So in insurance complaints, you go back to the insurance company, and if they do not solve this problem, so there is an ombudsman, which is a government appointed authority. Now that ombudsman has to listen to numerous complaints, and the complaints are increasing day by day. So what we have done is, when the customer comes to us, we aid him with particular points of information which he takes to the judge. Now judge, instead of asking him question, what happened, why why did you sign, who was the person who contacted you, he now reads that 10 pointer summary, makes a decision, and he has on record said that this has made my decision making ability 100 times faster. Because now he doesn't have to go into the history of the judgment and everything what has happened. Now he just has to look forward to those 3-4 points that can make him make the decision faster. So that is what we leave the decision to the discretion of that person who is supposed to make the decision. But we should make every possible attempt to make data points that can help that person make the right decision. And the customer will never be in a position to provide those data points, because he will have emotions on his side, will keep reciting the story and everything. Maybe what you can use this thing is, hear that story, make that model train on them, and then pick out pointers which will help. And this is happening in reality. But at the end of the day, decision making has to remain at the discretion of the person who is supposed to have that intelligence of viewing those data points and then eventually passing the judgment.
Particularly those areas where there's a human element involved. For enough areas where a human element is not involved and the decision needs to be made. Those things are, obviously you can have the system making those decisions at runtime. Yeah.
Somebody said yesterday, right, like doctors are refusing to use prediction, like diagnostic predictions we need, because they're afraid that this data, if they prescribe something against it, is going to be used to say that you gave the wrong diagnosis.
Oh, that's such a good example. That's such a good example. And I can easily see some of those possibilities shape up. Unfortunately, I don't have a good answer, but something like this will require our collective effort as a society to understand that just because something is suggested does not necessarily mean that it was the best. Okay, but the tendency, the more it starts getting accepted as a suggestive tool, the chances of creeping into that sort of a behavior is going to be pretty high. I have no answers better than just saying that collective awareness about the risks of doing something like that.
Can I ask that question, maybe piggybacking off of the question in the room a little differently? Is there some place where we as a community can agree and say that, look, these are applications we will never touch? I'll give you examples: predictive policing, sentencing, right? Defense applications, right? All of these areas where there's significant threat to life and property is one thing that comes straight top of mind, right? How much ever you commoditize or productize it in a certain way, they're always going to have spillover effects. And maybe I can, like, if you look at it historically, like 20 years ago, nobody relied on Google search, but today it is the first starting point for somebody, and a lot of people accept it as the possible truth, right? You can do as much awareness as you want that this is not going to work, but the real state of the society is that people rely on it, right? So are there places where we say that, look, we're not going to venture into it because the implications are too dangerous?
See, I get the sentiment behind it. It helps to a certain degree. It is it cannot be relied upon. It's something that I can also definitely tell you. Okay. Often enough, not often enough. It's almost a guarantee that there would be capable individuals who will get into this because it's one place to earn money. Okay, and they would figure out their rationalizations. So I don't think this we can encourage this as a thought process, but it is certainly not the answer. We have to understand its limitations. It can prevent statistically large amount of Janta from engaging in these sort of objectives, but you cannot stop it. And remember also that as some of these technologies evolve, a person with some degree of non-technical background can offload individual pieces to people who are capable but do not understand how these things are coming together. That's also quite possible. Okay, so it can't be the answer is what I'm saying. Much as I respect this idea.
Because a lot of frameworks that you look around the world are suggesting explainability as some sort of kind of silver bullet to a lot of these kind of applications, right? Like if you look at Niti Aayog and NASCOM, all these guys are talking about explainability, right? But if it's an intractable problem, right? Explainability isn't where you really want to hang on.
Right? I should elaborate on this because trying to derive explainability from the more atomic pieces of at a neuron level, that is the computationally intractable piece. Relying on the runtime reasoning ability of the model, highly unreliable explanation. Relying on the learned reasoning, bias. These are the three possibilities. Okay, there would be scenarios where some scenarios may bucket 1, some scenarios may bucket 2, some scenarios may bucket 3, some scenarios may none of these options become viable. We have to understand that this is the spectrum. Okay, but there would be scenarios where one of the three actually is sufficient.
So what do you see as the higher order effects of this? So like you said, in 2002 Google came. People were, a lot of that was only research data that was being published, and then Google now, as we know it, is everything. Right? Mm-hmm. So that's the higher order effect now. Your first port of call is Google, but now that is replaced by a singular search result as opposed to multiple search results when you look at ChatGPT and things like that. So what are the higher order effects of this? Because any derivative work that gets created, whether we want it or not, will start being influenced by this.
It's a very layered question actually.
That moves towards like that singularity piece that we're talking about.
That is something like it's a simpler thing for me to get into than what you are. This had got closer to with general AI and stuff like that. I think they are very far away. This is absolutely nowhere close to the how LLMs get used or how generative AI can be used at an audio level, visual level. It can pose significant societal threats, which can lead it to a different kind of singularity, the nuclear kind, but not the AI singularity kind of thing. We shouldn't be getting bothered. We are very far away from that. There's nothing in the architecture of that.
Just a clarification, this is not what I was referring to.
Okay.
Ways of thinking.
The ways of thinking. So the fact that the LLMs are all based on English language.
Yeah.
And then you can add translation capabilities, but the reasoning is based on a type of reasoning that exists within English language. For example, there are communities that have 50 words for snow. They can describe it in ways that I would never even be able to do. Right? What do we lose is there a risk to a singular type of reasoning being embedded in everything, all of our structures?
So empirically, choice of language does not impact reasoning significantly. And by empirically, what I mean is, no, even models that are, let me talk about first at an intuitive level, then I'll come to the empirical data about it. At an intuitive level, what language helps us receive a lot of new kinds of things, but when internally we are thinking about it, we are actually not our higher order abstractions are actually not based in language. They actually get represented in a more compact representation inside our brain. Whenever something is going in, it's almost like a filter that maps the incoming language into something like a more abstract space notion. And then when we are converting back it, there is the notion of thinking in a language, but it's happening at a much more outward layer than the most inner parts of how we actually think. Okay. The empirical evidence around it is, for example, models that have been trained in English, the amount of corpus that was needed to actually train them to be effective in English. Even a pure English model, you fine-tune that on a different language, the amount of training data that you need is actually much lesser. Okay, you don't have to invest in that. What that means is that your initial language with which you bootstrap that model captured both the language specific elements of the learning as well as the more abstract representations of some of the concepts. Okay, so whenever you are trying to onboard a new language onto the same model, which happens all the time when you are fine tuning a model onto a new language, only those, largely the language specific piece is what ends up essentially getting learned, because the underlying abstract semantic representations of those concepts remains the same.
Do you think that would be true if you took the first layer of the LLM as like a small indigenous community that has a completely different understanding of time, for example? That was trained initially there, and then you added the English layer, you think the results would be the same?
That's not the same example. I'll tell you why. Something that has a very different notion of time is not analogous, because see, when we are talking about different languages, let's say English versus Sanskrit, okay? Experiences of time between these two communities is exactly the same. Experience of the space around us is exactly the same. We see the same trees, leaves, and all of these things. The concepts that we encounter is the same. Okay? When you bring in a language where the experience constructs, concepts are fundamentally different, you're talking about a completely different literature. So that cannot be, that example that you're saying does not violate what I was suggesting earlier. I was talking about literature in different languages lead to the same concept, because we as humans actually experience the same things. I don't know if that makes sense to you, but that's...
Yeah.
But about, I have read somewhere that so for some languages, there are more words to explain some concepts. So in Malayalam, so I was talking to a friend who was a psychologist, and we were talking about why most people here don't understand a lot of feelings kind of thing. So we were having a larger set of conversation, and somewhere came that in Malayalam there are not much words for explaining, representing a lot of words. And then we were telling in Japan, we see a lot of...
That's a richness, variety, sometimes a certain rhythm, right? Yeah. That can be a little more appealing to us in some forms. That's a different thing than understanding. You get what I'm saying?
Okay.
Right? See, the point is that are there languages where it's impossible to explain some experienced phenomena?
Oh.
If that language exists, that language would make for a bad foundational LLM training.
Oh.
Okay? But in general, while the vocabulary, quality, quantity, rhythm, experience could be slightly different, almost all the modern languages at least are able to articulate, express every kind of phenomena that we experience. Right? Because of that, it should not matter what language you choose. English we end up choosing just because it has the largest corpus of data available for training. Right? You've got to think about it like this. Language is ultimately a representation. Is a just say I was just talking to somebody yesterday about transliteration, right? If in Hindi you are writing "aap kaise hain," if you write it in Devanagari or if you write it in English letters, a person who's reading it, so long as they can read the script, they are reading it in Hindi, correct?
Yeah.
Right. So what is happening is at a very initial level of your brain, things are actually getting transformed into the underlying representation. Same thing happens with languages. For example, when in mathematics, when we are thinking about exponential growth, okay, 1, 2, 4, 8, 16, 32. Whether you explain that to this to somebody in English, Hindi, Malayalam, their internal representation is not. Actually, there's a very interesting theory. I don't know how many of you are information theory fans, if you have background in maths, but there's this study that was done. The way neural networks learn is actually first they increase in capacity, almost like rote memorization, and then they unlearn.
Oh,
okay. In that quantization talk that I've done, I'd linked some papers. One of those papers is that. So they learn and then they unlearn. It's almost like how a kid, the first time that they might have come across the compounding formula, they might have just memorized it without really comprehending. They don't understand it, they memorized it. Okay. Then they saw that, I also came across this in physics when I was computing, or in chemistry when I was computing a certain chain reaction or something like that. Okay. And suddenly it clicks. Okay. When that clicks, that memory has been replaced by a much more distilled version of that concept. Okay, which happens to us all the time, which is why we focus so much on variety of learning, variety of experience, right? When we experience more variety, our brain is continuously distilling it out into more fundamental representations, much more compact, and our brain is immensely good at it. Same thing happens with neural networks. Okay, it learns and then unlearns. Okay, we measure that by something called mutual entropy and stuff like that, but fascinating thing for those of you interested in that part of it. So yeah, I mean, those are some of the reasons why I feel languages should not be mattering, but I do not have complete evidence to back that up, but I would be shocked out of my wits if that's the case. Fair enough. I think we've covered enough time, so we can probably end here. All right, thank you so much.
Thank you. I think you can teach us anything. We'll be sitting here the whole time.